Morning, students. In this video, we are going to discuss the precision and gyroscopic effect or gyroscopic couple effect on a four-wheeler automobile engine. So we are in the continuity. In the last class, we have taken to the gyroscopic couple towards the left-hand side due to the precision of an engine and wheels of a vehicle for calculating the velocity of precision, and the gyroscopic couple due to four wheelers, and the net gyroscopic couple, that is gyroscopic couple due to four wheelers and gyroscopic couple due to the rotating parts of an engine, and amalgam, that means the total content is of net gyroscopic couple, that is C and CW plus plus or minus C. So this is the content we discussed in the last class. So nextly, what is the effect of a centrifugal couple? So that is the topic we are in the present now. Actually, the vehicle moving along a curved path, there is a centrifugal force will act outwardly at the center of gravity of the vehicle. For this, the effect of this centrifugal force will also to overturn the vehicle. With that, the vehicle may uh, tilt, or during the turning at an higher speeds, the vehicle may be tilt and overturning during the left turn or right turn of any vehicle. So, what is the centrifugal force that is available means Fc is equals to centrifugal force, that is Fc is equals to m omega square by r. That is the total couple tendency to overcome the vehicle or overturning the couple is C naught is equals to Fc into h. That is the height also, it is the main consideration. That is Fc is m omega square by r into h. This overturning couple is balanced by vertical reactions which are vertically upwards on the outer wheels and vertically downwards on the inner wheels. So let us consider the magnitude of this reaction at the outer wheels, that is two outer wheels and two inner wheels, B Q. Then q into x is equals to c naught, or q is equals to c naught by x, where c naught is the couple tendency to overcome. Then overcome, that is fc, we substitute the c naught value in this, that is m omega mv square into h by r into x. The vertical reactions at each of the outer wheels or inner wheels be q by 2. That is we are taking only outer wheels or inner wheels. That is the main consideration. We know that the outer wheels are only 2 and the inner wheels are only 2. With that, q by 2 is equals to mv square into h by 2 or x. Then the total vertical reaction at all the wheels, that is at each of the outer wheels, is P naught is equals to four wheels, that is W by 4, plus outer wheels, that is Q by 2 and P by 2. And the total vertical reaction at each of inner wheels is W by 4 minus uh, P by 2 minus Q by 2. A little consideration is that when the vehicle is running at higher speeds, Pi, that is the reaction force for the inner wheels, Pi may be zero or even negative. This will cause the inner wheels to leave the ground, thus tendency to overcome the automobile. In order to have the connect between the inner wheels and ground, the sum of P by 2 and Q by 2 must be less than W by 4. This is the main criteria we have to follow for taking the turning towards the left or right, and at the same time the overturning is not to be allowed. So with that we can get it the no slipping of a vehicle during turning. And here there is a problem for consideration, that is the four-wheeled motor car of mass 2000 kg has a wheelbase 2.5 meters, and the track means the front two wheels gap or back two wheels gap. Okay. The height of the center of gravity is 500 mm and above the ground level, and lies at 1 meter from the front axle. Each wheel has an effective diameter of 0.8 meter and a moment of 0.8 kg meter square. The drive shaft and engine flywheel and transmission are rotating in the direction of at 4 times the speed of road vehicle in a clockwise direction when viewed from the front, and it is equivalent to the mass of 75 kg, having a radius of gyration 100 mm. If the car is taking right turn of 6 meters radius at 60 kilometers per hour, find the road on each wheel. So here we have to calculate the load on each wheel. So actually we can get it the W by we can get it the W by 4, that is a load on each vehicle. So further we are taking the consideration of the given data, that is mass of a car, that is M, and wheelbase 2.5 meter, x track 1.5 meter, and height of center of gravity, that is h 500 meters, 500 mm, that is 0.5 meters, L length 1 meter, dw, that is effective diameter of each wheel, it is diameter of the wheel, it is 0.8 meter, IW, that is moment of inertia, that is 0.8 kg meter square, and G is G is equals to angular velocity of engine parts to angular velocity of the wheels, that is omega E by omega W, that is 4, and ME is equals to 75 kg, KE is equals to 100 mm, and R is equals to 60 meters, V is equals to 60 kilometer per hour, that is equals to 16.67 meters per second. Since the center of gravity of a car is lies at 1 meter from the ground or front axle, and weight of the car is W is equals to mg, which is light at the center of gravity. Therefore, the weight on the front wheels and rear wheels will be different. So we, as in the case, we know that the all the vehicles shares the same amount of load which are acting on the axle, which is to be different from this problem. That is, here what we are considering, that is the front axle or the gravity of a car is lies at the 1 meter from the front axle. So with that we are taking the difference, that W1 with the weight on the front wheels and W2 with the weight on the rear wheels. For taking the moment about the front wheels, about a diagram, this with that, here in the diagram itself, the momentum, by constructing these type of diagrams, for that W2 into W2 into 2.5 is equals to W into 1, that is equals to mg into 1. So W2, that is in the question itself, 2000 into W2 into 2.5, that is where W is equals to mg, mass is nothing but the 2000, 9.81 into. So by taking all the momentum values for the front wheels, the W2 is with the value of 7848 newtons. We know that the car weight on the four wheels, that is the front wheels load and or the load on the front wheels and the load on the rear wheels. So for this consideration, we have to taken into the account of W is equals to W1 plus W2, that is equals to mg is equals to 2000. We know the W value, that is mg. So m is nothing but 2000 into 9.81, that is 19,620 newton, or W1 is equals to W minus W2. So there is a difference of the total weight and the front wheel axle weight. The difference is a 11,772 newton. Therefore, the weight on each front wheels is only the front wheels is 2. The weight is bearing is W1. So W1 by 2, that is equals to 11,772 by 2 is 5886, and weight on rear wheel similarly, that is the 3924 newton. Since the weight of a car over the four wheels will act downwards, therefore the reaction between the each wheel and the road surface of the same magnitude will act in the upward direction. So there is um, indication of the downward arrows and the upward arrows, that the reaction weights is in the direction of down and the reactions is of same magnitude in the upward direction. So these are all the representation in the uh, same color of indication also. Let us now consider the effect of gyroscopic couple due to four wheels and rotating parts of an engine, that is WE and uh, W sorry, omega E and omega W. We know that angular velocity of the wheels, that is V omega W is equals to V by RW, that is radius of the wheels, that is V is the linear velocity which we have solved in, which we have get it in the 60 kilometers 60 km per hour, that is of content in the hours. So we have to convert it to seconds, that is 16.67 by r, radius that is 60 equal to 0.278 radians per second. So the gyroscopic couple due to 4 wheels, a gyroscopic couple due to 4 wheels is equals to CW equal to I omega omega p into 4. Number of wheels are 4, so it is the thing that CW is equals to 37.1. This gyroscopic couple will tends to lift the inner wheels and to press the outer wheels. So in other words, the reaction will be vertically downward on inner wheels, that is wheels 1 and 3, and vertically upwards on the outer wheels, that is wheels 2 and 4. So let us consider P by 2 newtons be the magnitude of this reaction at each of the outer wheel. That is P by 2 is equals to CW by 2x. So this CW what we are getting here 37.1 by 2 into x. X is the gap between the back wheels, that is 1.5 meters. So that the totally final value is 12.37 Newton. We know that the mass moment of inertia of the rotating parts of an engine IE is equals to mk square for rotating parts of an engine. So IE is equals to ME into KE square. So ME mass of an engine is 75 into gyroscopic radius of gyration K, that is 0.1 square is equals to 0.75 meters square. Then the gyroscopic couple due to the rotating parts of an engine is I omega omega p, where the for engine we have to indicate the E, IE into omega E into omega p. So substitute all the values, we can get it the gyroscopic couple due to rotating parts of an engine as 34.7. And then this gyroscopic couple tends to lift the front wheels and press the outer wheels. In other words, the reaction will be acting downwards and on the front wheels and vertically uh, upwards on the rear wheels. So let F by 2 newtons be the magnitude of this reaction on each of the front and rear wheels. So F by 2 is equals to CE by 2B, that is equals to 34.7 by 2 into 2.5, that is 6.94 newtons. Now let us consider the effect of centrifugal couple acting on the car. We know that the centrifugal force, that is Fc is equals to m v square by r, that is equals to weight 2000 into v velocity 16.67 whole square by r 60, that is equals to 9263 newtons. The centrifugal force uh, we are calculated here, and the centrifugal couple is tends to overcome the car or overturning the couple, that is C naught is equals to CF into H, that is the distance, that is the height of the distance. Centrifugal force is acting at a distance of h, so 9263 into 0.5 is equals to 634631.5 newton meter. So for this overturning couple is tends to reduce the pressure on the inner wheels and increase on the outer wheels. So the reactions are vertically downward on inner wheels and vertically upward on the outer wheels. So let's consider the q by 2. Q by 2 is equals to C naught by 2x. So 4631.5 by 2 into x is 1.5, that is 1543.83 newtons. So from the figure we see that the load on the from the figure we see that the load on the front wheel 1, that is W1 by 2 minus P by 2 minus F by 2 minus Q by 2, that is the wheel 1 is nothing but the inner wheel but left hand, and wheel 3 is the inner wheel for wheel 1 and wheel 3 are the inner wheels, and wheel 2 and wheel 4 are the outer wheels. At the same time 3 and 4 are the rear wheels, and 1 and 2 are the front wheels. These are the for left turn. So for here we are taking the right turn, means in the problem for right turn 1 3 is the inner and 2 4 are the outer. So calculate this. From this, for wheel 1 W by 2 minus, that is, see here, W1 by 2 is in the upward direction of arrow, and next P by 2 is in downward direction. So P by 2, R by 2, Q by 2, these are all in the negative. So for this we are calculating that on load on the front wheel is W1 by 2 minus P by 2 minus F by 2 minus Q by 2. So all the values we can substitute here. We get it the load on the front wheel as 4322.86 newtons. In the same way, let us see from the figure what is the front wheel 2. Here the weight, that is W1 by 2 plus P by 2 plus Q by 2 minus F by 2. Okay, that is the diagram will shows the representation or directions of the arrow marks, that is upward and downward. Downward is nothing but the negative, upward is nothing but the positive. So three positives, W1 by 2 plus P by 2 plus Q by 2 minus F by 2. So this is with that the front wheels are always be negative of the F. So that is the magnitude of this reaction on each wheel, F by 2. Next rear wheel, all the values, that is W by 2 minus P by 2 minus Q by 2 plus F by 2. The value is 2374.74, and load on the rear wheel 4, that is P W by 2 plus P by 2 plus F by 2 plus Q by 2, which is 5087.14. With that, the method of solving of the four-wheel vehicle, or the centrifugal force or centrifugal couple which are acting on the four wheels. Then, and finally, last thing is the stability or the effect of gyroscopic couple on a two-wheeler, that is motor bike. So consider a two-wheeler of vehicle, either maybe a scooter or a cycle, motorcycle, taking on the right turn. So when we see in the diagram, first diagram, we can see engine, front wheel, and a rear wheel. So with that, what is the radius of track for right turn? So for right turn, in the see in the second diagram, for right turn we have to make a curvature of that is the centrifugal center of gravity and axis of active gyroscopic couple and axis of the precision and axis of the spin. So let us consider m is equals to mass of the wheel and its rider in kg. So here only not only the consideration of weight of the vehicle, we are considering the driver, that is rider's weight also. So weight of the vehicle and rider's weight is mg. So mass is m, weight is nothing but the into 9.81, and h is the height of the center of gravity of the vehicle and the rider. So rw is the radius of the wheels, and capital R is the radius of the track. Track is nothing but the path, and IW is equals to mass moment of inertia of each wheel. IE is the mass moment of inertia of the rotating parts of an engine. Omega W angular velocity of the wheel. Omega E is equals to angular velocity of the engine. Okay, these are the contents. IE, IW, omega E, omega W. These are the things we learned from the automobile four-wheeler also. The same formula may be reflected here. V is equals to linear velocity of vehicle, that is RW is equals to, or omega is equals to V by R. Theta is the angle of the heel, its inclination of the vehicle to the vertical for equilibrium. Now let us consider, this is the terminology, and let us consider effect of gyroscopic couple and centrifugal couple on the vehicle. Firstly, the gyroscopic couple effect. We know that V is equals to, omega is equals to V by R for both, for vehicle, that is a wheel. So we know the radius of the wheel. There we can get it the omega W is equals to V by RW, and at the same time omega of the angular velocity for engine parts, that is G into, we know the G is equals to omega E by omega W. So from directly we can substitute here G is equals to V by RW. Nextly, the total gyroscopic couple, that is I omega is equals to 2 into IW into omega W plus or minus IE into omega E. That is the total gyroscopic couple on wheels and on the engine parts, or engine rotating parts. So by substituting this 2IW into V by RW plus or minus IE into G into V by RW, for this we are getting the finally V by RW into 2IW plus or minus G into I. And the velocity of precision is omega P, that is V by R, that is the radius of curvature. And finally, when the wheels move over the curved path, the vehicle is always inclined at an angle of theta with the vertical plane. Okay, this vertical plane we are taking into the consideration in the diagram B. So for vertical plane to the wheel rotating is about the axis. Here there is an indication that in the diagram B, there it is an angle with the vertical is theta. So this angle is known as angle of heel. In other words, the axis of the spin is inclined to horizontal at an angle of theta, which is showing in the diagram C. Thus, the angular momentum vector I omega due to spin is represented by OA inclined to OX at an angle theta. But the precision axis is vertical, therefore, the spin vector is resolved along the OX. The gyroscopic couple C1 is equals to I omega cos theta into omega p is equals to V by RW into 2IW plus GR minus GIE into cos theta into V by R. So with that finally we get it a formula V square by RW R capital R into small r W into 2IW plus or minus GI theta IE into cos theta. When the engine is rotating in the same direction as that of the wheels, then the positive sign is used in the above expression, and the engine rotates in opposite direction, then the negative sign is used. The gyroscopic couple will act over the vehicle outwards, that is an anti-clockwise direction when seen from the front of the vehicle. The tendency of this couple to overturn the vehicle in outward direction. Then, for finding the effect of centrifugal couple, we know that the centrifugal couple is equals to F is equals to mv square by r. This force acts horizontally through the center of gravity along the outward direction. Therefore, centrifugal couple is equals to C2 is equals to Fc into H cos theta. Fc is nothing but mv square by r into H cos theta. Since the centrifugal couple has a tendency to overcome the vehicle, therefore total overcoming the vehicle or total overcoming overturning couple is equals to C naught is equals to gyroscopic couple plus centrifugal couple. By substituting previously, we are getting the C1 that is V square R RRW into 2IA and this C2. So by combining these C1 and C2, we get it the V square R by R into 2I W plus GIE by RW plus mg into cos theta. We know that this balancing couple mgh sin theta, we know that the balancing couple mgh sin theta, the balancing couple acts in the clockwise direction when seen from the front end of the vehicle. Therefore, the stability, the overturning couple must be equal to balancing couple. So this C naught is equals to mgh sin theta. From this we can get it the angle of wheel, that is the theta, so that the wheel doesn't skid. So with that there is no content of skidding uh, while taking the riding in a speeder manner, and at the same time particularly while taking the turnings also. Okay.